Welcome to another edition of Comet Algebra. This video is for Algebra 2, and this is the second part of Chapter 6, Section 5, Dividing Polynomials. In the first part we did long division. In this part we're going to do what's called synthetic division, and it's sort of a shortcut. It's another way to divide polynomials where we just pull the numbers out of the equation. The numbers are called the coefficients, and then we use the root. Okay, I need to distinguish. We use the root, not the factor. So these steps aren't going to make much sense just reading them. So how about if, as we read them, I go ahead and start this first example. So we're supposed to divide this polynomial by the factor x minus 2. Now when we were doing long division, of course, we used the factor of the entire x minus 2. Synthetic doesn't use x's, so we need to pull the numbers out correctly. If x minus 2 is the factor, then what is the root? In other words, x minus 2 is the factor. The root, x minus 2 equals 0, x equals 2. There's the root. So if the factor is x minus 2, the root is 2. So that's what we put in this little box here. I just draw half a box. So that's what step 1 means. Place the root in the box, not the factor. Step 2 says write the coefficients in descending order, inserting zeros if needed for missing terms. The descending order just means the highest exponent first and coming down. So here we do have an x to the third term. The coefficient on that term is a 3, so we pull that out. The next one in descending order would be the x squared, and that coefficient is negative 8. Now I hope you noticed that the x term is missing. There isn't one. So when there isn't one, we assume there's a 0x. So we do have to put the 0 in for the missing term, and then the constant is 14. So now we have completed step 2. Step 3 says you bring down the leading coefficient. And what that looks like, I sort of draw a line right here, leaving enough room for another row of numbers. So we take this 3 and we bring it down and we put it below the line. That's what step 3 of bring down the leading coefficient refers to. Now step 4, we start this multiply and add, multiply and add. What we multiply is the 2 times the 3 and get 6 and put it right here. And then we add straight down. Negative 8 plus 6 is negative 2. And then we repeat that. Multiply the 2 times the negative 2, and we get negative 4. And we add straight down. And then we multiply 2 times the negative 4, we get negative 8, and we add straight down of 6. So now we have to know how to interpret this answer. Since we divided an x out, we divided this x minus 2 out, so this 3 is no longer the coefficient of an x cubed term. Now this 3 is the coefficient of an x squared term. This negative 2 is the coefficient of an x term. This is the constant. And in this particular division, we had a remainder. And so there's a couple ways to write remainder. You can just put remainder 6. Another way that I believe your book writes the remainder, I'm just going to put the answer here again. They will take this remainder and put it over the factor that we're dividing by. And we used to do that back in 5th grade when you did long division. So they could write it like this, plus 6 over the x minus 2. Now when this remainder is 0, it just means that this factor goes in evenly. But sometimes it's 0, it goes in evenly, and if it's not, we have the remainder. So let's look at another example. Again, x plus 3 is the factor. The root then that goes in this little box is the -3. So always make sure you change it from factor to root when you're given the factor. Now let's start pulling out coefficients. In front of the x cubed term we have a 1. You'll notice the x squared term is missing, so we need to have a 0 there for the x squared place. The x coefficient is -7 and the constant is 6. Again, draw the line and just bring your first coefficient down to begin the process of multiply and add, multiply and add. So -3 times 1 is -3, add straight down. -3 times -3 is +9, add straight down. -3 times 2 is -6. This time the remainder is 0. That means that this does go in here evenly. So remember, we have divided an x out. So now this 1 is no longer the coefficient of an x cubed term. It is now the coefficient of an x squared term. This is your answer, which is what you would have gotten if we would have set up the long division like this that we did in the last section, or I should say the first part of this section. And a lot of people think this is easier. Maybe some don't, but had we done this long division, we would have gotten the same thing. The synthetic is just a nice way to work with only the coefficients. All right, one more example. Again, the factor is x minus 1, therefore the root is 1. Pulling out the coefficients, we have 3. There is no x squared, so I need a 0, 6, and -5. Draw the line, bring down the first coefficient, start multiplying and adding. Multiply and add. Multiply and add. And multiply and add. So we have a remainder this time. Now we could have been asked the question, is x minus 1 a factor of this polynomial? And so if we do this synthetic and you have any remainder here, we would have to say no. In our previous example, let me just scroll up here, when we got that the remainder here was 0, so here we would say yes, x plus 3 is a factor of this polynomial. I believe you're asked to do that in your assignment. So now we just have to write our answer. Remember, this 3 is no longer an x cubed coefficient. We divided an x out. So now the answer is 3x squared plus 3x plus 9 with a remainder of 4. So one detail I hope you noticed with all of synthetic, this is a really big deal. The fact that you accomplish something with synthetic division. When you divide one of these factors out that's an x, it brings the equation down. In our examples, we went from a third degree with a third exponent of a third, and we brought it down to a second degree. That's what we're going to use synthetic for in the future. So this is just something I want you to take note of. All right, so now you have the knowledge you need to do the synthetic division part of this section. So have fun with math.